Hi everyone, this is Mrs. Lee with Activity 4 support. And for this one, I'm going to be doing problem number 5, 6, and 7 separately with some uh, similar problems because they're all a little bit different. So if you see this one has a graph, and we're looking at the total distance walked. And here, this is going to be, and that is going to be miles, and here is going to be in time, in days. So this is our x, so that means the first day I walked, and when I say I mean like whoever, walked 2 miles, and then the second day, day 2, by the time it was day 2, they walked a total of 5 miles. And then 3, they walked a total of 9 miles. So from day 1 to day 3, they walked a total of 9 miles. Okay, so that's it's cumulative. It keeps on adding onto it. So it says for A, calculate the rate of change for each elapsed time. So from day 1 to day 2, so we're going to have to basically find 3 rates of change, or 3 slopes. Okay, so we're going to look for, I'm going to just do this on the right hand side, so I have a little bit more room. So we're going to say from day 1 to day 2, just like this. We're going to use the slope formula, or if you want to just think about it in this way, sorry, it's the change of y, it's how much the y changes over how much the x changes, right? Remember this this triangle looking thing is the Greek letter for delta. It's for like their d, if you want to call it that, which is for change. Okay, and so what we're going to do is, if you look at the y, it's going to be, oh, look at it went from 2 to 5, right? So I like to go backwards, so that's going to be 5 minus 2 if you want to find the difference. So 5 minus 2, which we know is 3, but we'll just write down the look. And then we're going to go 2 minus 1. So only 1 day has passed. So that'll be 5 minus 2, which is 3 over 1, which is just 3. Okay. So this would be 3 miles per 1 day. Okay. And then we're going to do the second one, so it's going to be 2, 5, 10, 3, 9. And if you look at this one, I will show you this one with the slope intercept, not the slope intercept form, the slope formula. That one you should be familiar with. If not, here it is right here. So again, this is the change of y, just like how we did up here, but this is the more formula version of it. So basically we take, it doesn't matter which one of these two, over the x2 minus x1. That's literally what the delta x means. We're just finding what the change is. What's the difference, right? When we say what's the difference, we just mean what's the subtraction, or the answer to a subtraction, right? So I always label this x1, y1, x2, y2, and then we're just going to plug in those numbers. So it's going to be y2 is 9 minus y1 is 5 over, and then x2 is 3, and then minus 2. Honestly, if you had flipped those two, it was 5 minus 9 and 2 minus 3, you would get negative answers on the top and the bottom, which would, if you're dividing negative and a negative, that would be positive still. So either way, it doesn't matter which one is your x1 and your x2, as long as you keep them consistent. So your 1s are on one point and your 2s are on the other point. So it doesn't matter which one you choose to be x1 or which one you choose to be x2. So 9 minus 5 is going to be 4, and 3 minus 2, happy days is 1, easy to divide. 4 divided by 1 is 4. So this is going to be 4 miles per day. So that average looks like it's a little bit higher. So, and if you notice right here, well, again, these are not drawn to scale, so we won't predict those actual slopes. And then we're going to look from the third interval right here. So this is going to be 3, 9, and 5, 13. Another way, let's see, another way for you to think about it is from 3 to this, if you're looking at just the x part right here, this difference right here is starting at 3 and going all the way to 5. How far did we go? Oh, that's 2. And then how far up do we go? So we started at 9 for the y, and we're going all the way up to 13. So that's a difference of 4, right? So my slope would be the rise parts of the y, so the difference of y, which would be 4, divided by 2. Okay, so we know, so this would be, our slope would be 4 over 2, or just 2. Okay, that's another way to think about it, graphically, if you're more visual. But we'll just do it the same way. So we'll take the same thing. So this time I'll make, excuse me, this one my x2, y2, and this is my x1, y1, just to change it up. And then we're going to have 9 minus 13 over 3 minus 5. So 9 minus 13 is going to be negative 4 divided by 3 minus 5, which is going to be negative 2. And so we know that negative 4 divided by negative 2 is positive 2 miles per day. And if you notice right here, that's exactly what we had said over here. Okay, so that's 2 different ways to look at it as well. So lots of different ways to think about rates of change. And so it's asking what is the, calculate the rate of change for each elapsed time. So I'll say interval 1. If I can write interval 1 is going to be 3 miles per day. Interval 2, so can I just say int 2 is going to be 4 miles per day. And then interval 3 is going to be 2 miles per day. There we go. And it says during which interval was their average speed the greatest? And I just put in there the least. So where was the greatest average speed? 4 miles a day. Not going very far. Or we're just walking. So yeah, that's quite a bit, especially if you're trying to stay at home. So we would say the interval 2 the greatest speed, average speed. Whereas, and so here the least is going to be on interval 3. Slacking, not good. So interval 3 had, so if you don't want to continue to write down the same thing, you can say the, and then since it's not greatest anymore, it's the least average speed. Okay? And those quotations is just to say it's the same word as the one right above it. So whenever you're doing a lot of repeats, we use that a lot in statistics. There's a lot of repeats. We'll just go, oh, it's the same word as above. So if you're taking notes in other classes and they're doing some things that are very similar, you can use that too. I use it a lot in my notes time. All right, so for the next one, we're going to the next number. All right, number 6. The table below represents the height of tennis paper airplane. I don't know if you're into paper airplanes, but one of my sons is. And with P of t, remember we say this right here as P of t. That's how we say it, not PT or anything like that. Representing the height of the airplane in meters, and t represents the time in seconds. And it's always good to state what your units are, because if you remember activity 3, units really do matter. If you haven't seen the video for activity 3, feel free to do that too. Just not right now, because we're working on number 6. Calculate the plane's average rate of change from 2 to 6 seconds in meters per second. So if you look at this table below, we don't need all of this information. The only information we really need here is this, where t is equal to 2 seconds. So if you notice right here, t is at 2 seconds. and t is equal to, oops, sorry, not that one, just t. It's not 7 seconds, it's 6 seconds. This is what happens when you don't read the time all the way through sometimes. And we'll go back to happy days. And here's 6 seconds right here. And so if we're looking at this from t to 2 to 6 seconds, we notice that it's going down. And if you know anything about rate of change, when it's going down like that, you are going to get a negative slope because it's decreasing. Phew, it's like, well, it's decreasing. Okay, so remember that is a negative slope. So here we go, one more time. We'll use our slope formula. If you remember our slope formula, it's y2 minus y1 over x2 minus x1. And here is our x1, y1, because why not, you came first, and x2, y2. Okay, and we're going to just plug those answers in. So from 1.1 minus 2.7, so 1.1 minus 2.7 divided by 6 minus 2. 6 minus 2. Okay, and we're going to just go 1.1 minus 2.7, which is negative 1.6 divided by 6 minus 2. That'll be 4. And so that's going to equal, just in case, there's sometimes we need negative 0.4. Okay, so we would say, remember we wanted in units again, so negative 0.4 meters per second. Okay, you can put S for seconds or SEC for seconds, meters, so this is what it is. And that's exactly what we had thought. It was going to be a negative slope and negative 0.4 meters per second. Okay, so that would be the slope of that airplane from 2 to 6 seconds. All right, and